through these answers for the homework. So the first one is asking us to draw some ionic compounds using the information given. So here we have lithium hydroxide. So a metal and a nonmetal. We have lithium, between lithium and hydrogen. We have lithium with 1 valence electron, and we have hydrogen with 1 valence electron. Remember, the nonmetal always steals the electron from the metal, so hydrogen should have 1 valence electron already. We'll steal the one from lithium, and then we'll end up with Li plus and H minus, and they'll stick together as Li. Next one is sodium and fluorine. So we have Na with its 1 valence electron, and we have fluorine with its 1, 2, 3, 4, 5, 6, 7. We'll have fluorine stealing the valence electron, so we end up with Na plus and F minus. And we have our final formula of Na. Calcium oxide, calcium with 2 valence electrons, and we have oxygen with 1, 2, 3, 4, 5, 6. Calcium is going to give up its 2 valence electrons to oxygen, and we end up with calcium plus 2 and oxygen minus 2, and our final formula is CaO. Last one is kind of the trickier one because we're going to need multiple chlorines to help the magnesium. So we have magnesium with its 2 valence electrons, and we have chlorine with 1, 2, 3, 4, 5, 6, 7. So one of those electrons is stolen by one chlorine. Then we add another chlorine to steal the other one. And so we'll end up with Mg 2 plus and 2 Cl's, Cl minus and Cl minus. So our final formula is MgCl, and we put a little 2 to indicate that there's 2 chlorines there. All right, so let's move on. Let's do the Lewis dot diagram showing molecular bonding. So here we're going to have 2 hydrogens for A, their 1 electron, and an oxygen with its 6 valence electrons. So we're going to share electrons here, and usually we pick the ones that are by themselves. So if we share here, and here. So we have our hydrogen now sees 2 valence electrons like it wants to fill its valence shell, and the oxygen will see 8. So if we count all of these, and let's change this to blue to show which ones our oxygen sees. So 1, 2, 3, 4, 5, 6, 7, 8. All the ones in the circle are shared between the 2. So oxygen now sees 8 valence electrons. It is happy. So let's try this with the rest of them. So B, we have 4 hydrogens and 1 carbon. I'm drawing it like this to show that it's just easier to lay it out. Usually, whichever you have less of will be in the middle of your element or your compound, and the others will be around the outside. So here we're going to have carbon with its 4 valence electrons, and we'll share. So each hydrogen gets to see 2 electrons, and the carbon sees 8 by the end. So the carbon is happy. So C, we have 2 oxygens. So this is when we see a double bond, which is always interesting. So the first one we're going to do just like we've been doing. Whichever electrons are by themselves, let's pair them up. So now we can go through and count how many electrons does each oxygen see. Should be 1, 2, 3, 4, 5, 6, 7. That's not enough, so we have to pair another one up. So now, if we go around, each oxygen will see 1, 2, 3, 4, 5, 6, 7, 8, and the other oxygen will see 1, 2, 3, 4, 5, 6, 7, 8. Remember, the ones in the circles are shared by both, so both oxygens are happy. So anytime you make one bond and your elements are missing, they don't have a full valence shell, they don't have 8 valence electrons, try drawing another bond, see if that will work for you. So the last one, 2 oxygens and 1 carbon. So we're going to have carbon and our oxygens. Because we have 2 of them, we'll put them on the outside. 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. 5, 6. Let's start pairing up. All right, now our oxygen sees 7. If you count them up, the other oxygen sees 7, and our carbon sees only 6. So we need another bond, and let's draw it between this. So now there'll be a double bond between carbon and oxygen, and a double bond between carbon and oxygen. And what that actually looks like when we do it in shorthand is we would have our carbon with 2 lines attached to our oxygen with its lone pairs with the electrons left over, and then double bond attached to our oxygen. With its lone pairs around it. So we should have 4 electrons around the outside. And that's what that would look like. All right, so moving on to the next one. So now we have a mixture of ionic and molecular. So let's go around first and identify which ones are ionic and which ones are molecular. So we'll put an I next to ionic and an M next to molecular. So remember, if we have a metal, we know we have an ionic bond. So we need our periodic table. Let's get it out. And beryllium, that is a metal, so that will be ionic. Aluminum, that one's okay. Carbon and sulfur, that one's molecular. Potassium and chlorine, that one is going to be ionic. And actually, yeah, aluminum and oxygen is going to be ionic because aluminum is a metal here. That is a metal if we look at our periodic table. So let's draw these out. A, B. So A. We're going to end up with Al. And remember, it's going to lose 3 electrons, so it will be plus 3. and oxygen will be -2. And when we work that out to figure out how many we need, we end up with Al2O3 because of the way the electrons are going to steal. For B, 1 carbon and 2 sulfurs. 1, 2, 3, 4. Sulfur, sulfur. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We're going to get shared electrons here and here, and then here and here. Notice that looks very similar to the carbon with 2 oxygens. So our final product, C, double bond, sulfur. Don't forget your pairs of electrons that are left over, and sulfur, attached carbon. All right, let's do C over here. Potassium and chlorine. So potassium will have a plus charge, chlorine will have a minus charge, so we end up with HCl. D, 2 nitrogens. This is a nice tricky one. There's actually such thing as a triple bond that we're going to see here. So nitrogen has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we'll draw our first bond. And each nitrogen should see 1, 2, 3, 4, 5, 6. So we need another bond. Now 1, 2, 3, 4, 5, 6, 7. And finally one more bond. And now each nitrogen sees 8 valent electrons. And the final form, that looks like this. 3 little lines attaching each nitrogen and the lone pairs left over. And that is, there's no such thing as a quadruple bond, but we can have single bonds, double bonds, and triple bonds in our elements if necessary. And basically the way you do that is you make everything have a single bond. If you still have valence electrons left, you can add those double bonds in. All right, let's do the last one, E, so beryllium, which is in group 2, so it will have a +2 charge. And sulfur, which is group 6, so it'll be -2, so then you just end up with BeS as your element. All right, so some of the word questions here. So can a covalent bond form between a metal atom and a non-metal atom? Explain. So no, covalent bonds form between 2 nonmetals only because they need to be able to share electrons. Metals don't have electrons that are able to be shared. So no, that can't happen. Number 5, how many covalent bonds join the atoms between N2? Why do you think nitrogen gas is so unreactive? So why doesn't it react very well? So there are 3 bonds between each nitrogen, and that makes it very strong. So it's hard to break down nitrogen once it's a gas. That's also why most explosives have nitrogen in it, because the nitrogens really want to stick together. If you let them, if you put heat to them, turn them into a gas, they will stick together and with a lot of energy, and it tends to explode. Which the following substances are probably electrolytes? So electrolyte means electricity, can conduct electricity, and we know those are ionic compounds, the ones with the charges. So which ones of these are ionic? That's ionic. That's ionic, and this is ionic. So the only one that is not would be here. That is a molecular compound. All right, which type of elements combine to form molecular compounds? Give one example, then describe 2 properties that would distinguish it. So nonmetals form molecular compounds with each other. For example, hydrogen and oxygen combine to form water. Also, carbon, hydrogen, and oxygen will combine to form glucose or sugar. 2 properties that would distinguish a molecular compound from an ionic compound are conductivity, so how well they conduct electricity, and